Good morning, good afternoon, everybody. Thank you very much for joining today's webinar, How to Expand Network Visibility in an Encrypted World, with our very own Matt Ellison. We're going to start in a minute. All right, so next slide. A bit of housekeeping today. So the webinar is being recorded. The recording will be available after this session. If you want to ask a question, please use the chat button or use the ask question button, and all question will be answered at the end of the webinars. So Matt Ellison, he is our speaker today. Matt has been specialized in cybersecurity for over 15 years across endpoint, network, and user technology, and has led teams in product management, product marketing, and technical sales. With previous roles at Symantec, Logarithm, and BAE System, Matt has extensive experience, has allowed him to work with numerous organizations across EMEA and APAC, helping them to understand how best to address the security challenges. So Matt, the stage is all yours. Thank you.
Brilliant. Thank you, Virginie. So fantastic to have you all here today. Thank you very much for joining this webinar. I hope that it will be interesting and useful. And as Virginie said, please do use those chat buttons and the ask a question buttons. It's always really good if we can get an interactive session going and we can get those questions answered. We will get to those at the end of the webinar, but yeah, if we don't manage to get through them all, then not a problem. We will try and get back to you, and hopefully you caught my LinkedIn details there, but please feel free to connect with me and ask me any questions there. So yeah, let's jump straight into it. So obviously you're here to hear from Corelight, and hopefully you appreciate that Corelight are best known as a network detection and response organization. We are the custodians of Zeke, the open source tool. And we describe ourselves because of that as an open NDR company. So yes, we do have a commercial operation, but we're equally supportive of the open source side of things as well. And we'll talk about both of those today. But let's get into talking about encryption and how we look at that from a threat hunting point of view. So firstly, you'll appreciate that with us being Corelight and the way that we do things, that we really feel that networks are a critical source of security truth. The reason for that is that nothing can happen within an IT organization without that traffic traveling across the network. Ultimately, that's why people focus on NDR these days, because it captures all of that traffic that goes in and out of the network and potentially that goes across your internal network as well. So when one endpoint talks to another, or a server or something external talks, then that's all captured. Those network packets have to follow the requirements of TCP/IP, and there is a huge amount of information in there that, as it says there, it tells us that holistic, objective story. So the things that we cover, we can talk about files, what happens there. We can talk about applications and how they interact. We can talk about servers. They're still key components within organizations' networks. And then obviously the users often, unfortunately, take the blame for many problems, but there's no getting away from them despite the rise of AI. And then the endpoints that we all use, which, as we all know, increase more and more every day. It's not just the old PC, but phones, tablets, laptops across many different types. And then databases, still a hugely important thing within organizations, whether on-prem or in the cloud, or even as a service. So let's dig down into it. So one of the things that whenever we talk about encrypted traffic that people always pretty quickly jump to is, what's the value of a tool like Zeke, or what's the value of network packets when they're all encrypted? you can't read what's within those packets. And there was a time when I used to talk about network detection, and we'd kind of talk about the fact that, yeah, sure, legitimate business traffic might be encrypted, but 90% of malicious traffic, they don't encrypt that. It's too much like hard work. You have to pay for certificates. It's there's too much of a paper trail around getting certificates. Well, of course, that's just not the case anymore. It's very easy to get certificates. It's very easy to actually create TLS links between malware and a controlled communication server. So there are definitely things that can be done, and we are seeing an increase in encrypted traffic attacks as a result. So this reference here is to some hackers that use DNS over HTTPS. So DNS, as I'm sure you are all aware, is very well established for exfiltration of data. It's a great way of getting data out of an organization without people ideally noticing what's happening. But it's also pretty easy these days if you've got a security tool or you use a SIEM of some type to create an algorithmic approach to look at the length of DNS records, the length of subdomains, things like that, the entropy of the content of the DNS records that are being searched for, and then pretty quickly spot that actually there's some very unusual DNS traffic going to exceptionally long subdomains of strange domains, things like that, and that's pretty easy to find. But if that's embedded in HTTPS traffic, then you can no longer do that analysis. You can no longer see the domain traffic that's, the DNS responses that are being given back or that are being used to exfiltrate that data. So yeah, using encrypted traffic from hackers is becoming more common. It's making life for the analysts much more difficult. So there are a lot more challenges in their day-to-day efforts. And add to that the increase in use of TLS 1.3, and it really does start to make quite an impact. Now, it's still fair to say that a lot of organizations, for a variety of reasons, will still push for TLS 1.2, but TLS 1.3 is out there. It is more secure. It's a lot more efficient and more performant. You're talking a much smaller number of packets from up to 3 packets versus the kind of 5 to 7 of TLS 1.2. So yeah, there are real benefits in using TLS 1.3, and as a result, that is making life difficult for organizations that relied on a lot of that information that was carried in the headers of TLS 1.2 to make decisions about how they intercepted that data. So that's all well and good. We all understand the benefits of encrypted traffic and the fact that we have to progressively change. There was a time when we all just used to talk about SSL. And of course, now nobody uses SSL, or they certainly shouldn't be, and it's been overtaken by TLS. And that's just going to continue to happen. Again, DNS over HTTPS, that was unthinkable a few years back, but now you've even got folks like Google pushing for DNS over HTTPS. So again, the considerations around privacy overriding the considerations around security in some situations. One of the other things that this always leads us to when we talk to customers is, well, okay, I'm faced with all of this encryption, but I have obligations as an organization, both to my employees, to my customers, and also to any compliance requirements that I have, where I need to make sure that I'm doing the right thing. So obviously, if you're an organization that's, for argument's sake, is in financial services and you're dealing with your customer details, their money, so on and so forth, or in fact, any organization that deals with customer data, you have to ensure that that data is protected. But if you can't see that data being extracted because the hackers have managed to use some kind of encrypted method of blocking that, then that can be challenging. So naturally, what people tend to do is they start to look at decryption, and they start to say, well, okay, we can't just blindly accept the fact that there's all of this encrypted traffic. We need to look at how we can introduce decryption, so we can actually look at this traffic in clear text, and we can start to understand what's going backwards and forwards and make sure that we're not going to fall foul of our customers or any compliance requirements or regulators or any of the other things that we have to worry about. But of course, that gets extremely challenging. I mean, some of the things that we can talk about here, the cost for anybody that has looked at decryption or indeed has purchased decryption, you will know that those solutions are extremely expensive. They have to be extraordinarily fast and extraordinarily powerful to be able to do what they do. So they often are very expensive. The performance can be frustrating because that decryption it takes a lot of compute power. So if you don't have the necessary level of decryption, then getting an on-time decrypted feed into your security tools can be very challenging, and often it can cause a lot of issues with the integrity of that data and the ability to effectively analyze it. And then, of course, as anybody that's been involved with this will know, it gets incredibly difficult because you can also find yourself violating individuals' privacy rights by decrypting their traffic. So there's often lots of allow listing to make sure that certain encrypted traffic can go through. And then, of course, all you're doing is making a rod for your own back, because that then becomes ways that the hackers can get traffic moving through that's still encrypted, but avoids the decryption processes that you've put in place. So decryption, absolutely, for some customers is great, but it can also be an extremely challenging solution to implement. Okay, so with all of that, you might be thinking, well, pretty much what do we do then? Just kind of throw in a towel. There's all this encrypted traffic. It's just going to continue. There's going to be more and more of it. And it's going to be incredibly difficult to do anything with. Well, at Corelight, we take a slightly different approach. And the analogy that we use is a bit like kids at Christmas, or actually not just kids, but adults too, where when you want to know what's inside a Christmas present, or some other kind of present that you've been gifted, then you shake the box. You give it a shake. Is it something soft? Is it something hard? Is it rattly? All of the kind of things that we do to get a sense of what's actually inside. And that's kind of how Corelight and Zeke works. So let's get into that a little bit more. So for those of you that haven't come across Zeke before, we're just going to look into the background of Zeke and how it works and what it does and how Corelight is able to take that. So again, just to reiterate, Zeke is a very powerful out-of-band network security monitor. It is completely open source. As it says there, you can go to www.zeek.org and you can get hold of it. And if you go to try.zeek.org, there is an entire online learning platform that you can dive into and really get a feel for what Zeke can do and how it works. It was invented in 1995 by Vern Paxson. Vern is still with us. Vern is part of Corelight. He runs the labs for Corelight, so still very, very heavily invested in Zeke and everything that it does. So for the organizations that use Zeke, they will take an out-of-band feed, so a span, a tap, or a packet broker, depending on the size of the network. And then the data that Zeke produces, as it says there, we transform that network traffic into logs. So 50 plus different logs, covers 35 plus protocols, and that is constantly increasing as we add OT and all kinds of new bits and pieces into there. We can extract files where it is unencrypted traffic. They can be reassembled and extracted and then used for sandboxing and so on and so forth. And then there is monitoring and detecting, which is probably what most of our customers do, and that's what we will be getting further into today. So you can have custom behavioral detections via a complete scripting language that's provided with Zeek that allows you to do full signature-based detections. So with regards to encrypted traffic, Zeek has 4 key capabilities. So the first one, kind of obvious, is the identification. So as those packets cross the network and Zeek analyzes them, it can immediately identify that there is encrypted traffic. Because of course, the headers of encrypted traffic initially, as that TLS handshake takes place, they have to be unencrypted. You can't, there has to be a negotiation between the 2 endpoints as to how that traffic is going to be transmitted, what certificates are going to be used, so on and so forth. So identifying that encrypted traffic, that's pretty straightforward. What we can then do is parse that traffic. So we can really look into that handshake, understand the cryptographic characteristics. So what actually happened with the handshake on that traffic, what was agreed, what certificates were exchanged, and what was the nature of those certificates. So really understanding what's going on in there. Outside of that, we can obviously correlate the unencrypted traffic that relates to that encrypted stream. So although the stream might be encrypted, as mentioned, components of it will be unencrypted, and we can relate the two and how they fit together. And then, of course, using all of that information, we can put that together and use it to analyze that encrypted traffic and really understand what's happening and what's taking place. So that's that concept of shaking the box. That's the approach that says, okay, I might not be able to actually go in and decrypt that traffic and understand in clear text what's contained within the payload itself. But within each packet, there is enough information that has to be carried in clear text that's passed backwards and forwards that I can understand everything that's happening around the context of this encrypted stream. So there's actually a huge amount of information in there that we can make use of. So some of the things that we will see and that we can help understand, parsing validation is really useful. So we can actually verify the connection protocol. So you can mess about with the headers, but ultimately there still has to be that real world connection, that real world agreement of how the packets are going to be exchanged, how the certificates are going to be understood, passed backwards and forwards. So we can really understand what's happening regardless of what the packets are trying to tell us is happening. So whether that's simple things like being on the incorrect port or things that are more challenging. As part of that, we will generate a separate log, as it says there, the dynamic protocol detection, DPD log, in addition to the normal protocol log. For those of you that know Zeek, you'll also know that there's a variety of other logs that are produced when things are strange or unusual. So we're not going to get into those today. We're not going to get into how those can be used, but they do, of course, also play a part in understanding when something untoward is happening across the network. But all of this plays into that thing of really understanding the commonly used encryptions and when something deviates from what we would expect to see as the norm. Now, of course, within that, there are some expected logs that you would see in those everyday approaches. So SSL.log, which relates to that historically SSL and now TLS. So as you can see there, I appreciate it's in pretty small text, but a huge amount of information relating to the certificate. For those of you that know Zeek, you'll see some of the common fields in there, and we're going to look into those a little bit more deeply in a moment into how they relate to one another. For SSH, still a extremely common tool that you will see almost kind of every day if you're in a network. As people log onto machines and work with them and do stuff with them. And then, of course, things like the X509, all that certificate information that's incredibly useful to understand what's happening within the network. So all of that information, as mentioned previously, is accurately extracted from the network packets and is assembled in those logs so they can be taken care of and made use of when you're doing your threat hunting or your analysts are doing their searching. Now, as we push down into that, it's not just how those specific encryption logs play with one another, but it's also how all of the common logs relate and how they all there's this relationship between the network traffic, as I mentioned earlier, that might be encrypted, and all of the ordinary things that take place to allow that traffic to move across the network and to just move across the internet in general. So that starts on the left-hand side with the con.log. That's where we track all of the connections that take place between any endpoints. So every network flow will have an associated con log. In that, again, I appreciate it's pretty difficult to see, but you can see a red box and a green box, unless of course you're red-green colorblind, in which case they will both look exactly the same, and apologies for that. So the timestamp is the red, and the UID, the unique ID for every connection, is the green. And what you can hopefully see across there is that within all of these logs, you have that commonality of the timestamp and the UID. So all of those files can relate to one another with regards to what happened within that stream, with regards to what happened with the encrypted traffic, and you have that nice common element across all of them. So as we can see there, as you would expect with any kind of connection that's using encrypted traffic, especially in this case where we're actually moving a file, you have all of that information. So the con log, the DNS log, the HTTP log, the files log, and the SSL log. So that commonality across all of them that allows you to understand everything that happened with regards to that encrypted traffic. So what was the DNS record that related to, how were the HTTP traffic moved along, and overall what happened with the connection with regards to those kind of low-level traffic patterns. So when you have all of that in place, that really allows you to do some really powerful encrypted traffic analysis. Now, some of you that have looked at this previously may well have heard of the JAR3 or J3 Zeek script. This was created a number of years ago by the JA3s because there was 3 individuals involved that all had the initials of JA. They were all at Salesforce, and they created this script to create client fingerprints that organizations are able to use, as it says there, to identify malicious communications. Now, this is fully open source. You can go and get hold of this yourself. So if you wish to try this with Zeke, that's pretty easy. You can go off and do it. It's actually available for a number of other solutions as well. You don't have to have Zeke. You can use the logs from Zeke and actually do the analysis within another tool. But if you go as per the link there to github.com/salesforce/jar3, you'll be able to see all of the relevant information and everything that's involved with regards to that. So let's go into that in a little more detail. Apologies, we've jumped through. Let's go back. There was a slide there that I've expected to be. So let's talk about this without having the slide I was expecting. And again, apologies for that. That's completely my fault. So JAR3 is an example of one of the scripts that we provide within Corelight and within the networks that allows you to take all of that Zeek information and to build it up and get unique client fingerprints as to what you can do with that. So you might kind of go, well, okay, that all sounds cool, but how does that actually play out in the real world? So as an example, there are certain malware tools that will have a unique fingerprint. So you can actually take the fingerprint that's produced and you can know that that fingerprint directly relates to, say, TrickBot, for example. So those fingerprints work very much like an MD5 hash for a malware file, whereby having that analysis of the way the tool works and the way the SSL pulls itself together, you can actually relate it to specific attacks. So that's obviously extremely useful because just having the process of that analysis performed, the production of that fingerprint, and then the ability to take that fingerprint and independently run it against a threat intelligence list of hashes or something along those lines makes for a very powerful ability to analyze those attacks that we spoke about at the beginning of the presentation, where you're really unsure of what's happening because the traffic is actually encrypted and you can't go into it and have a look at it. So JAR3 is a great example of how you can pull all of that together, how you can take that information that isn't directly encrypted, but the certificates, the handshakes, the way it's flowing backwards and forwards, build that fingerprint, and then actually understand what's happening and if it relates to something bad. So when we talk about that shaking the box, when we talk about the things that we do with regards to encrypted traffic, this is just one of the examples. There is an awful lot more that we have within there. So some of the other things that maybe aren't quite as dramatic, maybe don't relate so much to that kind of high level threat hunting, but things that are just really useful for an organization that are also achieved with Corelight and our ability to look at encrypted traffic are really simple things like certificates that are about to expire. So the ability to go and to look and understand that, do you know what, we've got 4 servers within the organization whose certificates are expiring in the next 3 months. Well, for anybody that knows, if you've had this where a certificate has expired and suddenly nobody can log on to a particular application or a particular server because the certificates are now out of date and they're rejected by the browsers or the other applications, however it might be, knowing that those certificates are running out of time, that they're about to be out of date, that's really, really useful. Other simple things include elements like self-signed certificates, the ability to see that communications are happening externally with a self-signed certificate. That's a really useful thing to look at, because in most cases, unless it's something that's kind of an in-house application or something like that, that's probably not a good thing. That's probably somebody that's using a certificate to encrypt traffic so it can't be seen by security tools, but hasn't gone to the trouble of creating a legitimate certificate that relates to a proper domain name. So again, a good example of something that's actually pretty straightforward to see, really good to get that information out, but leads to an interesting analysis and something that should definitely be further investigated. So on the back of that, let's just talk a little bit about Corelight. So as mentioned at the top of the call, we are enterprise class. We are a global organization that are in many organizations. Lots of the organizations we work with started off using open source Zeke and have progressed to use Corelight as an alternative, because we take all of the kind of really difficult stuff about running open source Zeke and make it much easier. And we look after everything concerned. But as I say, we're very focused on that open network detection and response, and we are fully supportive of that open source Zeke. We have the founders of Zeke working for Corelight, and we still actively maintain the open source Zeke. So we have a dedicated team of developers that look after nothing but open source Zeke, but they're on the Corelight payroll because we understand how important it is to maintain that open source tool, not just for the benefit of people using it, because it has such a rich environment and community and people that really develop for it. And certainly it's not unusual, as you can see with that JAR3 script, where we take work that was done by other people and we pull it into Corelight and share it with all of our customers and the improvements and additions as they go. So that's the kind of thing that makes life with Corelight much easier, because we take care of that. So yeah, 350 plus customers globally. Obviously that's growing all the time. So over 20 Fortune 500s and over 35 governments across 16 countries. So we do a lot of government work in terms of the size and level and capacity that we deploy to. A bunch of folks funding us, probably the key one there that's typically of interest is CrowdStrike. So we have a great relationship with CrowdStrike. They invested in us quite a long time ago, and we continue to enjoy a great relationship working with them. and we are headquartered in San Francisco. But yeah, we have teams all over the globe, so there's always somebody pretty close by that can help out and get involved. So just some examples, I'll let you look through there in terms of how folks use us for their security. Probably the big thing that we see with most of our customers, especially with the addition of our investigator tool a couple of years ago, is really the ability for people to accelerate past just kind of responding to alerts, and to really, as the middle one says there, it gives people that ability to properly start threat hunting. So instead of just taking an alert that's produced from a tool and just investigating each alert and having a look to see if it's bad or good, or maybe even just not knowing, we're much more about giving people a kind of an environment that they can look into that relates directly to their IT systems as they know them, where they know what's important, where they know what needs to be focused on, and they know what's normal. And then providing the information to be able to properly go in and threat hunt. And we're actually going to be covering that move from alert driven to threat hunting, not with the next webinar in this series. The next webinar in this series is going to be with Cribble. But the one after that, we're actually going to be digging down more into how you can move from an alert-based approach into building out some kind of threat hunting and eventually moving directly to being focused on that threat hunting approach and using alerts to inform what you do as a threat hunter rather than using them to drive everyday behaviors. So as mentioned earlier, this is the slide that I was thinking, it serves me right for not knowing the order of slides. These are the other kind of things that we scan for when we're doing all of that encrypted traffic analysis. So the things I mentioned there, the SSL certificate monitoring, understanding what's in place, the fingerprinting, and then all of the different analytics. So some that kind of sound kind of cool, but actually are incredibly valuable. So seeing that somebody is actually using keystrokes, so an SSH connection into a server, it's not running a kind of a script or something like that, but we can tell from the traffic patterns that it's actually somebody typing on a keyboard. So you may well have a server that nobody should be connected to and typing on a keyboard. So things like that, really, really useful, and a great way to do those kind of threat hunts. Let's look for keystroke detections across our environment. And then when you know which servers are which, because it's your environment, then you know which ones are deserve further investigations and which ones are normal. So yeah, a huge amount of information around SSH, RDP, and so on and so forth. So yeah, that's kind of my 30 minutes of presentation. We will throw it open to questions. So Virginie, I don't know if you have anything.
Yes, specific. Thank you, Matt. Thank you very much for your presentation. So I'm going to check. So you still can ask some question, use the question little button, and then I will be able to ask a question. I can already see one question, Matt. So do you think decryption will become more common given the compliance requirements on organizations?
Yeah, that's a great question. I certainly think that conversations about decryption will become more common. In fact, I have a lot more decryption conversations with customers now than ever before, which kind of seems obvious, I know, because encrypted traffic is just sort of the default. And I talk with many customers that worry. For some customers, they tend to worry more about the compliance side of things. They're worried that stuff's happening or getting out via encrypted traffic that they can't see. So I know that PII is a really big thing. But I also have spoken with a number of customers that have decryption in place, and it is an extraordinary time sink. if they can actually get it up and running. I was actually talking with one customer, to be fair, this is about 3 months ago, and they purchased a decryption solution about 18 months, and they still do not have a working deployment because it's just too challenging to work out what they can and can't decrypt, how they decrypt it. So much stuff breaks now because having that kind of decryption in the middle is it just kind of doesn't cut it. So it's a really kind of challenging environment, and I don't know that there is an answer to it. I think part of it relies in having better endpoint data. That's obviously one of the things that we talk to CrowdStrike a lot about is the crossover between network data and endpoint data, and understanding at the endpoint where stuff hasn't been encrypted yet, what's actually going on. And obviously that's where a lot of these kind of tools work when they're looking for personal data that's potentially being transmitted in a way that it shouldn't be. So I think there's going to be a lot of different alternatives, but I'm not confident that network-based decryption really has much of a future. In my experience and the customers I've spoken to, it's very expensive, it's very difficult to do, and you end up having to let so much stuff go through encrypted anyway that you very quickly question the value.
All right, I'm having quite a lot of questions on there, so I'm going to read you some out. Are you doing any more analysis of TLS, SSL, uncheck, except GA3, fingerprint, i.e. timing, data sent, etc., for broader fingerprinting, including the data traffic metadata?
So yes is the short answer. I mean, JAR3 is just one example, and probably the sort of the best known example of that kind of fingerprinting. There is a bunch of other stuff that we do. Some of it is exclusive to Corelight. So a lot of the encrypted traffic package that you get as a Corelight customer, that's content that we've produced. Or that we've kind of taken open source and improved and developed it. So yes, there is a lot more that we do. That slide towards the end that had a very high level stuff. If anybody is interested, then do let us know, and we can talk to you in more detail about exactly what we do. The other thing, of course, is to point out in all of this is that's the beauty of Zeke, right? The whole beauty of what we talk about here is that if there is something specific that you want to look at, that you want to investigate, and you believe there's a way that you can, in your head, you can think how to do it, then the beauty of Zeke and the way its scripting language works is that anything that's unencrypted, we can read. It goes into the log. All that you have to do is work out how to script what you do with it. So all of these tools, JAR3, all the rest of them, they've just come about because people have had that idea of, hey, well, I wonder if you could do this. The information's there. How do we put it together? Let's build the script, and then away you go. So yes, that happens with lots of stuff. It's being added to all the time, and as things change, we will no doubt find new ways of doing it.
Okay, I've got quite a lot of questions. So what is the main difference between open source Zeke and licensed Corelight with Zeke? Sorry.
Yeah, so there's a number of differences, and they're worth covering off. So the key one is probably scalability. Open source Zeke kind of has everything in it. It's built to sort of be the best tool it can for as many people as possible. What we do with Corelight is a little bit different. Firstly, we provide the sensors that the Corelight runs in. So whether that's physical, virtual, or cloud, we build that sensor and we give you, now there's a number of different ways that we do it, the different kind of approaches, but ultimately we're giving a performance sensor that has a certain level of functionality. So let's start with the physical ones because it's easiest to wrap your head around. We can go from a very small sensor that will do a few hundred. We have customers that actually have minuscule amounts of traffic going through the sensors, like literally that they're monitoring OT technology and they've got a few K running through, right the way up to customers that have terabits per second, or sorry, terabits per second of data running through their sensors. And we have the hardware to do that. And on top of that, we've built all of the functionality for how we actually have multiple sensors, how you can work with packet brokers to split data across multiple sensors, how we can have those multiple sensors all ingesting that data into one endpoint, but still maintaining all of that integrity and understanding all of the flows and how they work. So all of that is the normal kind of things that challenge customers when they're working with open source Zeek, because tying together, for instance, lots of separate open source sensors is quite challenging. And then on top of that, it does come down to the support. It comes down to things like our customers get technical account managers or phone access to technical account managers. We add in lots of specific scripting. We can help you with developing stuff that's unique to your environment. So we have those kind of skill sets to be able to help as well. There's a few other things, but I don't want to take forever just kind of turning this into a sales pitch for Corelight.
Another question, do you have any recommendations for learning Zeek and analysis of related logs?
Yes, so the starting point is definitely go to try.zeek.org. It's really, really cool. It's all fully interactive. It walks you through understanding how Zeek works. If you wish, you can play your own packet captures through the little system that they have there, so you can actually muck about with your own network data. The other thing that I would strongly recommend is go online and look up Corelight at home. Now, this is something that needs to be done with a business email address. It's not kind of freeware, but it's a tool that we do for our customers, prospects, partners. But it does have to be underwritten by, there's a legal terms and conditions assigned to using it. So just, that's a great way of experimenting with Corelight. You get the equivalent of one of our software sensors. You can run it on a Raspberry Pi, and you can do it at home, provided you can sort of do some kind of network tap on your home network. Then that's another fantastic way to learn Corelight and understand how it works.
I have some more questions. The audience is really keen on this subject. Do you see any difference in terms of demand or requirements from an NDR service from enterprise versus governmental customers?
Short answer is no. It's a really interesting question, because what actually happens is we do often see different organizations of that nature, public versus private, treating things differently, and they probably shouldn't. So historically, by the nature of where Zeke came from, it historically has been more biased towards public organizations. That kind of open source nature and the way it works. But we're starting to see more and more private organizations. I think that what we've seen over the last couple of years, which is the kind of challenge, and our competitors have gone in different directions, and we've sort of inherited some of what customers want. If you look at Zeke historically, it's very much about generating those logs, putting the logs into something like Splunk or LogScale, and then building dashboards around it. Now, of course, that's quite challenging. It's quite high end, and it tends to be those larger government organizations that have the staff and the abilities. So it's much more challenging especially for smaller private organizations to be able to achieve the same ends. So, there's a lot more GUI based applications now. We've introduced Investigator, which really allows you to accelerate that threat hunting, but also very quickly exposes the log search if you need it. But at the high level, you've got that GUI that you can go into. So whilst I say no, people should have the same outlooks and the same approach, I do understand that there are different ways to achieve that end. And I think that certainly from Corelight's point of view, we're working very hard to make sure that regardless of how customers approach things, whether it's from that sort of old school log search and dashboards, or whether it's from the sort of more kind of GUI based, we're giving them the same results, but via different interfaces.
More questions, carry on. Is Corelight currently working on further detection in the encrypted traffic category? And what is on the roadmap at the moment?
Yeah, so we are always working on new detections, not just in encrypted traffic, but that's definitely one of the areas where we do a lot of work because there's so much of it. But yes, when I mentioned Vern earlier, the original creator of Zeke, he runs our labs team, and that's a pretty large team of people located around the globe. Yeah, they are constantly building new detections, enhancements, looking at new ways to do things. Apart from encrypted traffic, the other thing that has exploded is using Zeke to analyze OT networks and the traffic that goes across there. Because of the way Zeke works, it literally starts at the kind of physical level. So if you can plug a network cable into a card, then we can start looking at the traffic. So there's a huge amount of benefit to be gained there as well. So yes, that is a never-ending task. In terms of the roadmap, specifically to labs, I can't think of anything specific that comes to mind. We are kind of one of those organizations where there is updates to everything every few weeks. So yeah, it's there's always something just around the corner.
I've got more questions. Are you okay to still take some more questions?
Yeah, sure. Keep going.
Really enthusiastic crowd today. Do you see that the threat hunting use cases you have mentioned around encrypted traffic based on the Corelight scripting and logging are sufficient to dissect TLS 1.3 artifacts? Or,
yeah.
Sorry.
No, go on.
Should I add further decryption capabilities for more visibility?
So what I would say in that situation is, yeah, the change from TLS 1.2 to 1.3, if you look at the kind of that initial exchange when the connection is first built, it's dramatically more efficient with TLS 1.3, and there's good reason for that. There was some strange quirks in TLS 1.2 that hackers were able to take advantage of. The ability to renegotiate certificates midstream and stuff like that. So TLS 3 does away with a lot of that stuff, but it's also easy to get caught up in the specifics around the handshaking. Now, that's all great. It's really useful. Even with TLS 1.3, there's a whole bunch of information that we still extract and make use of because it's in clear text. But also don't forget that with every single packet, there's a whole bunch of open text information because there just has to be. So even though the payload may be encrypted, there's still really useful information just in each packet about what's going on. Specifically as to whether that would be enough, that really kind of depends on whether you have any specific requirements. I mean, ultimately, we talk about how we do this kind of shaking the box and how we analyze the encrypted traffic and the things that we do. And that leads to some very, very useful outcomes where you can absolutely identify that hackers are doing stuff that they shouldn't be doing, even though you can't see the payload. But this leads us down the conversation that we have around packet capture, for example. We have our smart PCAP, a selective tool that allows you to define which packets you capture. And one of the big things about our PCAP is that we drop encrypted payloads. Typically, we can capture a small amount of them, but typically we drop it because there's no point. Why would you keep a whole bunch of encrypted stuff that would take forever to decrypt? But we absolutely still work with many customers who will say to you, no, we do full packet capture, and we will always do full packet capture. Now, that's great. I don't think you can actually do much with the packets you've captured when they're full of encrypted content. But still, for some people, you'll see stickers on laptops, PCAP or it didn't happen. So yeah, I think for some organizations, there's an element of, and for some analysts as well, there's an element of wrapping your head around what's relevant, what's necessary to address what's happening. For others, there will always be that thing of, well, unless I can see what's actually in the packet with clear text and I can decrypt it, then I'm not going to have enough information. So there is always a pull in both directions, and that's whether that's around skill level, cost, time, whatever it might be. The key thing here with what we're trying to do and what we're talking about is giving you that accelerated information around what's going on with encrypted traffic without having to look at those decryption solutions, without having to dig further into doing more. But as mentioned earlier, there are other roles that other tools play, especially at the endpoint where where stuff's going on before it's actually encrypted.
I have one question, you may have answered it. Is it possible to upload a PCAP file on Corelight system for malware analysis and get a result containing encrypted traffic attacks and malicious traffic that might exit the PCAP file?
Yes, it is. Yep, absolutely. You can play PCAPs through Corelight, no problem.
Okay. And I think that's the last question. There's a way for TLS decryption with Zeke, but it is indeed a very complex setup. But I can't see the, okay. Very complex setup, but aren't symmetric keys used to decrypt the data inherently, have the danger of being decrypted themselves and allowing attackers to decrypt encrypted traffic? Sorry, I'm not sure I get the question.
No, yeah, I know where that's coming from. That's and yeah, I get it that there's technically, I mean, so Zeke can be used for some phenomenal things. I mean, the scripting language and the way it works, you can you can use Zeke to do stuff that's got absolutely nothing to do with Zeke, weirdly. But yeah, we don't do and we don't advocate any decryption via Corelight. That's not something that Corelight offers. It's not something that Corelight does, because as the person asking the question inferred, there are significant risks around doing that, and that's not something that we offer or do. We don't use any kind of certificate type stuff. We are literally just looking at the clear text information associated with every network packet. So yes.
I have one last question, I think. How much presence do Corelight Zeke have in the cloud?
Yeah, a huge amount. So we do sensors for each one of the major providers. We have Azure sensors, Google sensors, and AWS sensors. Many of our customers are moving to the cloud. In fact, I've spent most of last week working with a customer who is building out an entire new infrastructure in Google, and they are deploying Corelight sensors within each of the VPCs that they are building out. So yeah, we still have a huge physical presence because there's an awful lot of customers. For instance, one of the biggest things that we'll have is we have air-gapped sensors. So clearly they're physically separate. and that is not going to go away. But more and more people are moving to the cloud, and that's definitely a big thing.
Okay. I'm sorry, there's one last one after. Thank you very much. The last one, I swear. How do you see quantum computing and improved encryption being analyzed with Zeke in the future?
No idea. Way beyond my pay grade, that one. Yeah, quantum computing. I mean, I'd be fascinating, and I know that there's a lot of talk around how that can both encrypt and decrypt. Not something that I have any level of knowledge or skill on, other than having read the odd article here and there. But yeah, at this point in time, definitely not mainstream enough for me to have to worry about, probably in the rest of my working career. But hey, you never know. So yeah, watch this space.
Okay, well, thank you very much, Matt. It's been a really great interactive session. As Matt mentioned, we have another webinars on the 22nd of February with Scribble. It will be Unified Endpoint and Network Telemetry for any SIM. So looking forward to see you next month as well. And thank you, Matt, for your presentation.
Thank you, Virginie. And thank you, folks, for all attending today. I hope it's been useful.
Thank you. Bye-bye.